Hi everyone, I'm Pratik from Logistimo. We've put together a product demo here through which we like to showcase the most important functionalities of our product. Here's a glance into what's to come in this demo. I'll be showing you how stock registers can be digitized by clicking a picture of these registers on our mobile application. I'll show you how supervisors can empower the workforce by liking the performance of the people that they manage. I'll show you how deliveries can be auctioned out to transporters. I'll show you how critical supply chain events can be displayed as stock tickers on television screens. Before we get into the product demo itself, I'll start off with the high level overview of our system as well as the problems that we're trying to solve. Primarily in the public health space, we see that there are three categories of problems, and these are the problems that we're trying to solve. Firstly, there's the problem of low visibility and poor supervision of the supply chain. And this is primarily because there are very few data digital interventions in healthcare supply chains. Even when there are digital interventions, we see that they are restricted to the district level. They don't percolate till the last mile. And more often than not, these data, real-time data is unavailable, and there's still a reliance on physical registers and whatnot. So because there is a lack of data into the last mile, there's also low availability of healthcare commodities and lost sales. This results in frequent stockouts and compromised health outcomes. What we also see is that even in areas where there are digital interventions, there's an inability to transform these data into insights. Finally, the highest order problem that we see is that of low efficiency and high wastage, and therefore high working capital in these supply chains. This is primarily because there's a reliance on heuristic policies, and there's a lack of use of data in decision making as well as policy making. To overcome these challenges, we designed our system on the principles of bottom-up empowerment. Uh, Logistimo is resilient to the conditions prevalent in emerging markets. What I mean by this is our technology works on practically any Android smartphone. It works on any sort of connection. It works just as well on the higher connectivity channels such as Wi-Fi or 4G, but it works just as well on, let's say, like a basic 3G or 2G or even GPRS connections. We also have a fallback method, which is SMS, which kicks in if there's absolutely no internet connectivity. We also have an offline mechanism as well, which comes into play when there is absolutely no network connectivity in terms of internet or phone connectivities. The system is also easy to use. It's simple to use for even first-time users of digital technology. What we've seen is that people can be trained, first-time users of digital technology can be trained to become power users in less than 1 day. And we see that the older users, people in their 60s, pharmacists in their 60s, are just as comfortable using the application and are just as active as their younger peers who are in their 20s. The system is designed and built for scale. We can scale to thousands of nodes, millions of transactions, and terabytes of data in almost any time, almost no time. It's also smart in terms of both machine and social intelligence. I'll deep dive into examples of this machine and social intelligence in subsequent use cases that I'll be demonstrating. And most importantly, the system is interoperable with almost any third-party technologies and legacy systems. We have open APIs, which can be leveraged to pipe data in or out of our systems and communicate with third-party technologies, which would capture data which is complementary to the supply chain data that we capture. So what does all this mean? The data flows into our system via, let's say, a smartphone device on which data entry is performed, or a barcode scan or RFIDs. We also integrate with IoT solutions, and that's another way in which data flows into our system. So this data can flow either through SMS, GPRS, or NFC channels. We also have online and offline capabilities. So this data is hosted on the cloud. This is where the data is held. We support all the standard supply chain functionalities such as inventory management, order management, and also a lot more. And I'll deep dive into specific use cases in the demo as we go ahead. And the data is fed back into decision makers via the channels that they are comfortable with. It could be a mobile device or a computer or a laptop computer or even a television screen. And essentially all the role players in the supply chain, be they manufacturers, wholesalers, distributors, or in a public health scenario, a national depot, state depot, or a last mile facility, and or even a central level orchestrator who's at a central level has a bird's eye view into the system. All these decision makers are fed back data by the system in a manner in which they are most comfortable, and also on devices with which they are most comfortable interacting. In addition to overcoming the fundamental supply chain challenges that I had initially spoken about, our system can unlock several greenfield opportunities by combining the data that we collect on our system with other third parties or IoT devices that would capture data which is complementary to the data that we gather. So this is really made possible by the interoperability features of our system. We have open APIs through which it's very easy to get data in or out of the system. We are open, our technology is open core, so we have a proprietary offering as well as a publicly available offering. We support IoT devices. It's very easy for us to integrate with different IoT devices. I'll give you an example use case of how we integrate with temperature monitoring loggers in a subsequent use case. We also adhere to all of the web standards that are out there. So what does this mean? Our existing capabilities, coupled with our capability to work well with IoT devices or third parties, unlocks several greenfield opportunities. Examples of which are 3PL, wholesale distribution, channel coordination via revenue sharing. So we can help improve the capacity of users, and we can also do customer segmentation. Again, I'll deep dive into some specific use cases in the subsequent demo. Moreover, I'd like to emphasize that we know that supply chains are not static, they change with time, and our technology is designed to evolve with these supply chains and stay relevant as the supply chain changes over time. And really stay relevant with respect to time, as well as stay relevant anywhere in the supply chain. So Logistimo can be applied to any node of the supply chain. So a node could be a warehouse, it could be a clinic, it could be a refugee camp, or it could even be an individual who's carrying metal commodities on a backpack. So what we've done is we've put together 7 use cases through which we try to demonstrate our product capabilities. The first one is data capture at the last mile. I'll demonstrate how a few different methods by which we can capture data at the last mile. We'll then do vendor managed inventory, where I'll show you how Logistimo supports the informed push model, where vendors can place orders on behalf of a last mile facility. We'll then cover bundled orders and fulfillment, where I'll demonstrate how we can physically track the commodity as it moves from the vendor to the customer facility. We'll then do a use case of inventory optimization or forecasting, where I can show how our system has been used to save several millions of dollars for one of our clients. We'll then do a big data analytics use case, where I'll demonstrate some of the reports and dashboarding capabilities of the system, where I'd like to bring out how we can synthesize insights from the data that we gather. We'll then do an IoT integration use case, where I'll take temperature monitoring loggers as an example. We'll then end with the workforce empowerment, where I'll demonstrate Logistimo Pulse, which is an application which can be used to monitor the workforce on the go as well as empower the workforce. Let's get started with the first use case. The first one is data capture at the last mile. I'll be demonstrating a few different methods through which we can capture data at the last mile. Now, this is how we've modeled the supply chain. There are 5 echelons. We have manufacturers who send stock to the central level facility, which sends stock to the state or province level facility, which provides stock to the district facility, and then we have the primary health centers, which are at the last mile. Now, this is a relatively simple supply chain structure. But we see that on the ground, supply chains are more complex than this, but we've kept it simple for the sake of the demo. But Logistimo does support all sorts of complexity and all sorts of relationships between echelons in the supply chain. We also gather geocode related data. So this data is really helpful if you're doing a system redesign project or route optimization. And now I'll be logging in as the pharmacist at the Hubli PHC, and I'll be showing you how data can be captured at the last mile. I'll be switching between screens now, between the presentation itself and my mobile screen application, which I'm projecting on the screen here. Now, this is the application. It's called Logistimo IOTA. It can be downloaded from the Google Play Store. So what I do is now I'll click on the app. We support a few different languages, English of course, and as well as Hindi, Bahasa, French, Portuguese, and Spanish. It's relatively simple to add new languages. We can do that whenever there's the requirement from the country in which we're deployed. It's password protected. You enter the username, you enter your password, and then you log into the system. So the data should load in a few seconds. The first time that you log in, it takes a few seconds to load, but subsequently it should take hardly any time. So when I log in, I see a few different cards here. I have inventory, I have orders, I have assets, and I have profile. So I go to inventory if I want to do any transactions with respect to my own store. It could be issuing stock, it could be discarding stock, etc. I go to orders if I want to place an order, if I want to interact with an upper echelon or a lower echelon. I go to assets to manage non-transactional items. It could be a refrigerator, or it could be a bed in a hospital, is another example. There's the profile section where I can view my own details as well as details of my vendors and customers. I can click a picture of my facility and upload it. I have the pharmacist can click a picture of himself or herself and they can upload it as well. It's some personalization features of the application. So I'll now go to inventory and I'll show you how an issue transaction, we call it an issue transaction, but this is essentially a consumption or a sale transaction at the last mile. So when I go into issue, I see the different healthcare commodities, and I see that I have 22 emergency drugs, I have 157 essential drugs, 4 malaria drugs, 11 TB drugs, vaccines, etc. So let's go into emergency drugs. I open up that card and I see the different commodities listed underneath. I have ASV dose, I have 11 units of ASV dose. This is what this indicates. I also see that there are different colors. So I'll quickly explain what the different colors mean. If a commodity is in yellow, it means that it's below the minimum stock threshold. If it's red, it means it's stocked out. If it's white, it means it's optimally stocked between the minimum and maximum thresholds. If it's blue, it means it's overstocked. So in a subsequent use case, I'll talk about how we go about setting these thresholds. It can be based on historic consumption data, or it could be based on a heuristic number as well. But I'll go ahead for now. So let's say I want to transact upon ASV dose. I'll click on ASV dose. I see that I have 11 units in stock, and these 11 units are expected to last for a day and a half based on my historic consumption. I see my minimum threshold here. I see my maximum threshold. I see some price related information. And I see that there are 2 batches of this particular commodity that I have in stock. So this is the first batch, this is the second batch. These batches are arranged on a first expiry, first out basis. The system is urging me to issue first from the stock that is expiring earliest. So let's issue 1 unit from this batch. I'll say save. I can perform transactions for multiple commodities at the same time. Let's transact upon this one as well. Let's say save. I get an opportunity to review the transactions that I have entered. If everything looks good, I'll go ahead and I'll hit submit. When I hit submit, what happens is in real time, this data syncs to the server, and every echelon in the supply chain is made aware of the stock position of this particular facility. If they want to see what the stock position of any commodity of this facility is, they can do so. So everybody has visibility into the supply chain. And also, if a particular transaction results in an anomalous event, such as a stock out, all the role players in the supply chain are intimated of this via, let's say, an SMS reminder. Or they could also log into the web application or their own mobile applications and view these stock positions. So what I've done now is shown you how data entry can be performed by punching in the numbers on the mobile application. But what we can also do is simply scan a barcode of a commodity and essentially do the same issue transaction that I performed. So what I'll do is I'll go to enter issue. I'll click on this barcode icon, and on my phone, a barcode reader opens up. And this is, I have an item here, and I have a barcode at the back. What I'll do is I'll simply read this barcode, and it comes up on my screen. And now I can just go ahead and I can transact upon this item. Now, this is another way by which we can do data capture. So another thing that I'd like to demonstrate is what we call the snap and load functionality, which is essentially all you need to do is click a picture of a physical register or a physical data entry form, and our system can essentially digitize this information. So where this is useful is what we see is in several of our deployments. There's a government mandate that physical registers be maintained alongside, let's say, data entry on a mobile or a digital application. So in such a scenario, to reduce the burden on the users, what we can do is simply click a picture of the register, and our system will go ahead and digitize this information. So I have a form here. So I have the name of the commodity here. I have the batch details here. I have the category of the item here. I have the opening stock, consumption, which is the sale quantity, as well as the closing stock. And you can see that the data here is handwritten for the batch details as well as the quantity of the items. What I'll be doing is I'll be clicking a picture of this form, and I'll show you how it can be digitized. So what I'll do is I'll come to capture form. Right. So on my mobile application, the camera opens up. I have a form here. What I'm doing is clicking a picture of the form. Now, first, what the system is telling me, it's asking me if it's got the orientation right. If this is the top of the form and this is the bottom of the form, it looks good. So I'll go ahead and say done. Now, what happens is the form gets processed on the application. Next, what it should show me is it would have scanned the data on the form. It would have also detected the borders of the form, and it'll ask me to check if it's identified the borders correctly. So this is the blue line is the border. It looks fine. It looks like it's identified the borders correctly. I'll go ahead and say done. Now what's happening is the data is being digitized, and on my screen I can see the data that has been read from the physical form, and it's been digitized. So I click on the verify option, where I can do a quick scan and check if it's done a good job of detecting my handwriting. If there are any errors, I can very easily override it. So far, it looks okay. Okay, so I see an issue here. It looks like the way I've written the number 4, it's detected it as a 6. So what I'll do is I'll override this. Everything else looks good. Okay, so that's the only error that I found, and I overrode that. So what the system is doing now is it's giving me feedback in terms of the errors that were made. It's saying that the character 4 had the most errors, and it's asking me to be careful in the way I'm writing the number 4 in the future. And the verification process just took about 53 seconds. And now the data is digitized. It'll sync with the server, and just as I performed data entry via entering the data, another way in which I can perform data entry is by simply clicking a picture of the form. So what I've done here is I demonstrated data entry via mobile application, a barcode scan, as well as the OCR functionality. But we can also perform data entry via the web application, via voice commands, or bulk upload of Excel files. And I'd performed the issue transaction now, but we can also follow a similar process to perform discards, to perform receipts, to perform return transactions, or to do stock corrections on the application. Currently, we gather about 36 million transactions annually on the system, very similar to the transactions that I just performed. And these transactions are synthesized and insights are generated from them. Let's now start with the second use case, which is vendor managed inventory. In the public health supply chain, what we see is that, let's take an example of the last 3 echelons. Let's take the state, district, and the last mile facilities. Now, the district facilities would place an order to the state facilities, and then there are deliveries from the state facility to the district facility. Then the district facility would wait for the last mile facility to place an order, and after which there would be deliveries from the district facility to the last mile facilities. In private pharmacies, what we see is that more often than not, the orders placed by the last mile facilities to the district are on credit as well. And once the cycle is done, then there's consumption at the last mile. Now, the system is essentially a full supply chain all the way through. The system would work well. We see that it works well at the district level, but then it would only work well at the last mile if the last mile users are diligent enough and if they're placing the orders on time. right? So, but more often than not, what we see is that there is a delay in placing orders by the last mile facilities. This results in stockouts and lost sales at the last mile. It also results in a lack of consolidation of these deliveries at the district facility because the orders are ad hoc. There's no chance of doing any sort of aggregation, and the distribution is pretty ad hoc. And this leads to high working capital in terms of the transportation costs. It also leads to frequent stockouts at the last mile because more often than not, these pharmacists at the last mile are not placing the order on time. So instead of that, because Logistimo is present and there is visibility into the last mile, the district facility has visibility into the stock position of the facility at the last mile. What we suggest is from the state to district level, we can continue the process as is. It could be a pull based supply chain. But then the district facilities could place orders on behalf of the last mile and send out the deliveries without having to wait for the last mile facilities to place that order. And of course, there's consumption or sales at the last mile that would go ahead as is. Now, what happens is when there is an informed push system from district to the last mile, now the service levels are much higher at the last mile. We see fewer stockouts. We see that inventory is optimized to a large extent, and we also see that there's a possibility of scheduling the milk runs from the district to the last mile. And when this happens, the entire transportation process is more regulated and more efficient on the whole. I'll now do a demonstration of how vendor managed inventory can be accomplished on the Logistimo system. I'll be doing this on the Logistimo web application. So this is the interface of the Logistimo web application. This is what I see when I log in. I've now logged in as the district facility at Dharwad. This would be the facility which is supplying stock to the Hubli facility, which I had logged in earlier on the mobile application. We'll cover these charts later on. I'll just for now I'd like to bring your attention to this banner which is on top. So this banner is telling me that there are 44 units that are about to be stocked out in the next 7 days. So this is based on my consumption patterns at these different facilities. The system is telling me that there are 44 units that are likely to stock out. So I click on that particular banner. Here what I should see is a list of all the facilities where these items are likely to stock out. Right. So what I see here is the Hubli facility seems to be the biggest problem area, where 41 facilities are likely to stock out. There are other facilities where about one item is going to stock out at each of these two facilities, and these other facilities look okay. So I click on this Hubli facility, and now what I'll be able to see is I'll be able to see all the particular materials that are going to stock out. So this indicator, this warning icon is telling me that this is the commodity that is likely to stock out. So this is one, and I should see the others listed here as well. We have all of these items listed here. So now that I know where the problem area is, which facilities are going to stock out soon of which item, what I can do is I can proactively go and place an order to this facility. So I'll go to orders, I'll say create order. Now I want to create a sales order as the Dharwad facility, which is the district facility, to the Hubli facility. I can enter a sales reference number, this is essentially, if there's a number on a physical form and I want to tie that physical order to a digital order, I can do that. I can tag this order as an emergency routine order, or I could even create a new tag if needed. And now I'm expected to enter the date by which I expect this item to arrive at the Hubli facility. Let's say I approximate that it will take about a week. I can type in some comments if required. Over here, I can see the stock at my own facility. This is the district facility. If I click on this box, I should see the stock at the Hubli facility. So based on stock position of the Hubli facility, I can now go ahead and place orders to that particular facility. So I know that ASV dose is low on stock. I see that this item has stocked out. So let's go with these two items here. So here what I can see is This is the stock on hand at the Hubli facilities. There are 10 units which are in stock. The maximum threshold is 500 units. So what the system has done is, based on the stock on hand as well as the maximum thresholds, it's recommending to me that I place an order for about 490 units. Right? And the same goes for this other item. So this is just a recommendation. I can always go ahead and override this recommendation. Let's say I feel that 490 is not required. I'll just go with 300. So the reason this could be, I'll say that there's a shortage of this commodity at my facility. Now, whenever a user enters a reason for deviating from a system recommendation, this data is gathered by our system. It's captured at the back end, and this helps us improve our forecasting engines even further, so that it gets more and more closer to what the user would actually enter. So this looks good. I'll go ahead and submit this order, and I'll say OK. Now an order has been placed. And this is the order ID, and all the role players on the system are sent SMSs telling them that an order has been placed. So as a vendor, I've placed this order. My customer, the Hubli PHC, would have been sent an SMS telling them that an order has been placed by this person, by your vendor, and you can expect this order on such and such a date. So right now what I see is this order has been confirmed, but it looks like it requires an approval for me to go ahead and ship this order. So what we see is in the public health scenario, more often than not, there's some person somewhere who needs to approve an order before it progresses, before it's actually shipped. So what I can do is I'll go here and I'll request an approval, and the approver, whoever has to approve this order, is again sent an SMS. He has to approve that order. So what will happen is the approver will on his interface, he will go here, and this is what it looks. This is what the approval screen looks like for him. And I should now see a new approval request for this particular user. Yeah, so this is the request. So there's an order that's been placed, and the system is asking him to approve this order. So I'll go ahead and I'll hit approve here. I now see that the order has been approved. Now this is the time at which the order was approved, and this is the person who approved the order. Now that the order has been approved, what I see is that the system has gone and automatically allocated stock. Now this allocation is done on a first expiry, first out basis. This is the batch ID for ASV dose, and this is the batch ID for the other item. Now if I want, I can go ahead and deviate from what the system has recommended. If I do not want to allocate stock on a first expiry, first out basis, I'm free to do so. The system will not prevent me. I can go ahead and change this allocation. But now that the stock has been approved, I can go ahead and I can ship this particular order. There's also a stage known as ready for dispatch. Now this is an optional stage which I can go to if I want to indicate to all the stakeholders that this item is ready to be picked up. But I'll go ahead and I'll ship this order. Now before shipping this order, the system is asking me to fill in some details. Now these details are required to be filled in because the system is completely integrated with respect to the order placement as well as the fulfillment or the delivery of that particular order. Now when I put in the details here, these details will automatically be sent out to the transporter. This could be a 3PL transporter or an internal fleet that we're running. Now I'll say that there is one package that has to be transported. I'll say that the weight of this package is about 7 kilograms. I'll enter the volume. Let's assume that it's a cuboid of 10 inches on all sides. I'll also go ahead and enter the approximate value of this consignment. I'll confirm the date at which I expect it to reach. Let's say it's 14th of September. And now I'll go ahead and I'll submit. So now what happens is in the back end, this information is passed on to the transportation orchestration service. In a subsequent use case, I'll demonstrate how this plays out with respect to the driver, and how on the driver's delivery application, a pop-up message comes up and it tells the driver to pick up this item from this location and deliver it to this location. So the last stage of an order is the fulfillment aspect of it. So the fulfillment is done by the receiving store. So once the order physically reaches the receiving store, then that operator will do the fulfillment of that order. I'd also like to touch upon the fact that as an item goes from one stage to the other, at the back end, any discrepancies that occur are being captured. For example, if the store has requested for a certain amount of a particular material, but upon confirmation, if that quantity is reduced by the vendor and he only partially fulfills that particular request, that discrepancy gets captured at the back end. What is also captured is the time that an order takes to go from one phase to the other. For example, the time that it takes for an order to go from the ship state to the fulfilled state is the delivery lead time, and that lead time is captured by the system on the back end. Now, these discrepancies as well as the lead times are very important because our algorithms, which help bring efficiency into the supply chain, are powered by the data that is gathered as a material flows from one stage to the other. I'll go back to my slides now. So I just done the demo now. I done the demo using the Logistimo web application. I'd shown you how vendor managed inventory can be done, but we can do the same thing on the mobile application as well. And I'd currently shown you how we can do VMI or push orders, but the system also supports system generated orders. So no human intervention is required. We can set up the system. We can set it up such that as in when a particular stock threshold is breached, it could be based on days of stock or it could be a fixed value. As in when a threshold is breached, the system will automatically trigger an order on behalf of the vendor, and there's no human intervention required at all. He just needs to ship it as and when the commodity physically leaves the facility. We can also place purchase orders on the system. The system also supports inter-echelon stock rebalancing, which is essentially the stock doesn't need to move from the vendor to the receiver store. If there are opportunities to move stock within the echelon from one facility to another facility, that can be done on the system. What the system does, it proactively identifies such opportunities. So an example that I could give is let's say a batch of a particular unit of a particular material is going to expire in the next 14 days. The system sees that based on the consumption patterns of the particular facility, it would not be able to consume these items in the next 14 days. Then what the system will do is it will recommend that batch, some units of that batch is moved to an adjacent neighboring facility which has the capability of consuming these items before it expires. So such opportunities are surfaced up to the administrators, and they can then go ahead and initiate these inter-echelon stock rebalancing opportunities and physically move the item from one location to the other, so that there is no wastage of this item.